Welcome to AI for GIs, Introduction to Artificial Intelligence. This is Class 7, Prompt Engineering, from basic instructions to advanced techniques. Same AI model, same intelligence report, two different prompts. One produces a 3-sentence summary that misses the key threat. The other produces a structured analysis that identifies the critical pattern your unit needs to survive. The difference? Not the AI's capability, the quality of your prompt. Prompt engineering represents the discipline of constructing inputs that translate human intent into instructions large language models can process effectively. This is not a technical specialty delegated to data scientists. It's a core competency for any leader who will task AI systems with operational work. This class examines prompt engineering through frameworks and techniques applicable across all commercial and military LLM platforms. You'll learn the PTCF framework mirroring 5-paragraph OPORD structure, parameter configuration controlling output characteristics, and techniques ranging from zero-shot prompting through advanced methods like retrieval-augmented generation and chain-of-thought reasoning. The final section synthesizes these components into context engineering frameworks that organizations deploy at scale. By the end, you will know how to bridge the gap between human abductive reasoning and AI inductive pattern recognition. Apply the PTCF framework to structure effective prompts for military applications. Configure LLM parameters for different task requirements. Select appropriate prompting techniques based on task complexity. And evaluate when advanced techniques like RAG justify additional token costs. I'm Dr. T. Justin Webb. Leaders excel at abductive reasoning, generating explanatory hypotheses from fragmentary intelligence. You see scattered enemy preparations and make the intuitive leap connecting observations into coherent theory about adversary intent. Large language models can't do this. They operate through inductive logic, deriving patterns from training data and applying those patterns to new inputs. The response represents highest probability continuation based on statistical regularities. This creates a fundamental problem. Direct interaction between abductive human cognition and inductive AI processing produces technically correct outputs that miss the strategic point entirely. Prompts bridge this logical gap. An effective prompt doesn't just ask a question. It provides the context, constraints, and structural guidance that enable the AI's pattern matching capabilities to produce outputs aligned with human strategic intent. Research reveals a striking pattern. Successful prompts average 21 words in length. Typical user queries fall under 10 words, less than half the effective threshold. Think about what this means for your organization. That staff officer submitting, "What should we do about the enemy?" isn't getting poor results because the AI is inadequate. The problem is a 7-word query lacking context, constraints, and output specifications. The quality principle governing prompt engineering states that AI output quality equals prompt quality. This isn't hyperbole. The most capable model deployed with inadequate prompts produces inferior results compared to modest models deployed with excellent prompts. Organizations that invest heavily in premium AI systems while neglecting prompt engineering discipline waste budget on unrealized capability. For military professionals, this framework is not novel methodology. It's direct parallel to structured communication you already know. A soldier who can write a 5-paragraph operations order already possesses the foundational logic needed to construct effective prompts. Persona assigns the LLM a specific role, focusing responses by drawing upon training patterns associated with that role. Task defines the specific action the AI must perform. Clear, concise, unambiguous, comparable to the mission statement in an OPORD. Context arguably represents the most critical component for military applications. LLM response quality depends directly on context quality. Without proper context, the AI operates in vacuum, applying generic patterns divorced from operational specifics. Format specifies desired output structure. ensuring the response is immediately usable without extensive reformatting. Beyond prompt content, you control LLM behavior through configuration parameters. Understanding these settings proves analogous to choosing appropriate level of initiative for subordinate units. Low temperature settings between 0.0 and 0.2 produce deterministic outputs. The model consistently selects tokens with highest probability. This proves ideal for extracting specific facts from intelligence reports, generating checklists from SOPs, and translating documents where accuracy proves paramount. High temperature settings between 0.8 and 1.0 increase randomness and creative diversity. This proves effective for brainstorming novel courses of action, generating potential enemy deception plans, or red teaming friendly plans. The strategic principle: fact-critical work demands low settings, creative tasks justify high settings, and consistent outputs require temperature locked at 0. Top P, also known as nucleus sampling, controls the probability threshold for token selection. This setting directs the model to select from the smallest token set whose cumulative probability exceeds threshold P. Typical settings range from 0.9 to 0.95 for most operational tasks. Top K restricts the model's selection to the K most probable tokens, regardless of their combined probability. For example, Top K set to 40 limits consideration to the 40 most likely next words. The interaction between temperature and Top P determines overall output diversity. Low temperature with low Top P produces highly deterministic outputs. High temperature with high Top P maximizes creative variation. Match parameters to mission requirements rather than accepting default configurations. Zero Shot provides direct instruction without examples, relying entirely on the model's ability to understand task requirements from description alone. Works well for simple tasks with clear instructions. Few Shot addresses limitations by providing 2 to 5 examples, establishing desired pattern before presenting the actual task. Email and memorandum writing represents the second most common LLM use case globally. The real-world impact proves substantial. Military staff officers write dozens of memos weekly. Few Shot prompting enables consistent format and professional tone, while reducing drafting time from 15 minutes to 2 minutes per document. System prompting establishes standing instructions applying to entire conversation sessions. The iterative process treats prompt refinement as normal workflow. Iteration is normal. Expect to refine prompts rather than treating refinement as indication of poor initial construction. Multi-layered prompting breaks complex tasks into sequential steps, each addressed through separate prompts. This technique maintains control and accuracy across complex workflows by enabling review of intermediate outputs before proceeding. Consider enemy course of action analysis. Layer 1 handles data collection from intelligence reports. Layer 2 addresses pattern analysis generating potential enemy COAs. Layer 3 conducts wargaming for each COA. Single comprehensive prompts attempting all 3 layers simultaneously often produce outputs mixing data errors with sound analysis, making verification difficult. Multi-layered approach separates verification of factual accuracy from evaluation of analytical reasoning. When Layer 2 produces inadequate analysis, the problem traces to analytical reasoning rather than data quality verified in Layer 1. Chain of thought instructs AI to show step-by-step reasoning before producing final answers. This technique dramatically improves performance on multi-step problems by forcing the model to work through logical sequences. Trigger phrases include "think step by step" or "let's work through this systematically." Performance impact proves substantial. Research shows accuracy improvements of 20 to 40 percentage points on complex reasoning tasks when chain of thought is employed. Cost impact is modest. Chain of thought increases token consumption by showing intermediate reasoning steps, typically adding 20 to 30% to output length. For logistics feasibility analysis requiring sequential calculation, Chain of thought guidance ensures the model works through mathematics systematically, producing verifiable analysis rather than plausible sounding but incorrect conclusions. Self-consistency represents advanced technique that generates multiple responses to the same prompt, then selects the most common answer through consensus voting mechanism. Process involves running identical prompts 5 to 10 times with temperature above zero to produce variation, comparing outputs to identify consistency patterns, and selecting majority answer. Military application. Red team assessment generating possible enemy actions for upcoming operation. Run the prompt 7 times. 7 responses produce pattern. 4 recommend establishing defense in depth along ridgeline. 2 suggest mobile defense. 1 proposes spoiling attack. This provides higher confidence than single AI output, though at cost of 7 times the token consumption. When to use self-consistency. Critical decisions where single error proves unacceptable. Reserve this technique for genuinely high-stakes analysis. Tree of thoughts extends chain of thought by exploring multiple reasoning paths simultaneously and backtracking from dead ends. Military parallel, course of action analysis, and wargaming. Process generates 3 to 5 initial approaches, explores consequences of each approach, evaluates which paths lead to viable solutions, and backtracks from approaches proving infeasible while pursuing promising branches. Consider developing courses of action for asymmetric threat in urban environment. Branch 1 explores direct assault options. Discovering collateral damage constraints make this infeasible. Branch 2 explores isolation and containment. Determining this proves feasible but time-intensive. Branch 3 explores infiltration and precision targeting, evaluating as most promising approach. The multi-branch exploration identifies viable solution by systematically eliminating infeasible approaches. Here's what separates effective organizations from those wasting resources. Understanding that 90% of work succeeds with basic techniques. Only 10% of tasks benefit from advanced reasoning approaches. The fundamentals covered in basic prompting, parameters, and core techniques provide capability for 95% of organizational requirements. Advanced reasoning techniques share common characteristics. They increase token consumption substantially, require longer processing time, demand human oversight to verify reasoning chains, and prove worthwhile only when problem complexity justifies overhead. Organizations should deploy advanced techniques selectively for genuinely complex problems rather than treating them as default for all work. Match technique to problem rather than over-engineering simple tasks. Retrieval augmented generation combines AI text generation with external knowledge retrieval, addressing the fundamental limitation that LLMs only know what appeared in training data. RAG enables integration of current information, classified materials, or proprietary documents unavailable during model training. G2 intelligence sections process real-time threat assessments from classified reports never seen during commercial model training. React alternates between reasoning and taking actions through tool use. Operations officer planning air assault asks, "Can we conduct helicopter insertion at landing zone Falcon tomorrow?" React checks weather API, observes winds at 25 miles per hour exceed safe threshold, and recommends delay. 7 cutting-edge techniques total exist for specialized knowledge-intensive applications. These address the remaining 5% of requirements after fundamentals cover the first 95%. Pattern 5 demonstrates the power of few-shot prompting for military correspondence. Staff officers write dozens of memos weekly. Training schedule changes, meeting notifications, policy updates. Few-shot prompting teaches format through demonstration rather than lengthy specification. The AI learns proper memorandum structure, appropriate language formality, and organizational conventions from examples. Time impact reduces drafting time from 20 minutes to 3 minutes per unit announcement. across an organization generating 50 memos weekly. The time savings total nearly 11 hours weekly, or approximately 560 hours annually, equivalent to 1/4 of a full-time staff position. Context quality and simplicity first approaches determine success over advanced methods. Prompts are cognitive translation interfaces bridging human abductive reasoning and AI inductive pattern recognition. The logical gap requires explicit context, constraints, and structural guidance. PTCF framework provides military adapted structure parallel to OPORD construction. Context arguably represents the most critical component for military applications. Match parameters to mission. Low temperature for facts, high for creativity, 0 for consistency. Configuration parameters control output characteristics as precisely as you choose level of initiative for subordinate units. Start simple. 90% of tasks succeed with basic techniques. Organizations that chase every new technique waste effort on experimental approaches while neglecting fundamentals. AI systems amplify human intent, mediated through information environment quality. Precise intent, expressed through well-structured prompts within well-managed contexts, produces precise outputs. In our next class, we'll explore Class 8, DW AI Infrastructure, Gen AI. Understanding the military AI infrastructure and deployment platforms that operationalize the prompt engineering principles we've covered today. Stay connected with AI for GIs on TikTok, Instagram, YouTube, and LinkedIn. Daily insights on AI and military applications. Visit the full course below. I'm Dr. T. Justin Webb. Thanks for joining me for AI for GIs.